Hi everybody. We're going to be continuing our lesson of triangle similarity today. Yesterday we did angle-angle similarity with triangles, and we did side-side-side similarity with triangles. And today we're doing our last postulate, which is side-angle-side similarity. So we're going to start with filling in our blanks here. Remember, two triangles are similar when their angles are congruent, but their sides are proportional, not congruent. They're proportional. So, right here, if two sides of one triangle are not congruent, proportional, if the two sides are proportional to two sides of another triangle, and their included angle, that means the angle in between the two proportional sides. So when you have a triangle, this would be your included angle. It's in between the two sides. And their included angles are congruent, so the angles have to be the same size. Then the triangles are similar. Cannot write. Okay, so we're going to take a look at these two triangles here. I'm going to go ahead and give these side lengths an actual length, like 4, and they're congruent. They both have 2 slash marks. And this one I'm going to give them a side length of 2. And they're both congruent to each other because they have the 1 tick mark. And they're proportional because 4 over 2 is the same thing as 4 over 2. So these side lengths are proportional, and their their included angle is congruent. They're both 32 degrees. So these triangles are similar by side angle side similarity. So we can go ahead and write our similarity statement. Triangle XYZ is similar to triangle XYZ would be ABC. Triangle ABC. Okay, so let's actually look at some problems. On example 4, we have 3 different sets of triangles. We're going to actually look at example A in class, so we're going to look at example B and C right now. So if you look at example 4B, you notice that these triangles are actually facing each other. So they are flipped versions of each other. So if we look at side 9 right here, FH is 9, we have to realize that 9 corresponds with 3. Okay, these are the two correspond to each other. 15 here corresponds with 5. Also, you have to ask yourself, where is the included angle and are they congruent? Well, the included angle are right here. These are the two included angles, and they are congruent because these are vertical angles. So we're hoping that if these sides are corresponding and proportional, then these triangles are similar. So 9 over 3, is that the same as 15 over 5? And yes, because we know that 9 divided by 3 is 3 and 15 divided by 5 is 3. So yes, these triangles are similar by side angle side similarity. So our our similarity statement, it doesn't matter if you start with a small triangle or the big triangle as long as you go in the correct order. So let's just start with a small one. DFE, triangle DFE, is similar to triangle D. Again, remember, all the way across to the other side, H would be corresponding to D. H, F, G. Okay? Let's go ahead and look at example 4C. You notice we already have congruent angles up here. But one thing I notice, even though 1 over 2 is the same thing as 2 over 4, they're both 1/2. The problem with this is that this angle is not included. It is not in between our two sides. Here are our two sides, so our angle needs to be this one. Angle X and angle R are the included angles. Since we don't know what angle X and angle R are, we have to assume that this is not similar because we would need to know these two angles instead of Q and W. So we cannot write a similarity statement there. We're going to save example 5 for class, and we're going to go ahead and look at the proof right now, example 6. We are given that quadrilateral ABCD is a parallelogram. This symbol right here means parallelogram. So ABCD is a parallelogram, and that is given. So if you look at it, here is ABCD, and it looks like a parallelogram on your paper. Okay. Now it's saying that DC is parallel to AB. Here's DC on top, and I'm going to mark it with an arrow. And here's AB on bottom. I'm going to mark that with an arrow. Those arrows mean that they're parallel. And the reason we know that they're parallel because what is this? This is a parallelogram. So we know that the sides are parallel because that's what a parallelogram is. Definition of a parallelogram. I'm going to call it a p-gram for short. Okay. Now it's telling us we've got some congruent angles. Angle DCF, so this angle up here is congruent to angle EBF, so this angle here. So notice, remember, these are parallel lines, and they're being cut by a transversal. So these two angles that I just marked are alternate interior angles. So they are congruent by the alternate interior angle theorem. Okay. We're also given that angle DFC, I've got two arcs there, is congruent to angle EFB. So those two angles are congruent not because they're alternate interior, but because they're vertical angles, and vertical angles are always congruent. And then we're trying to prove that triangle BFE, and this actually should not be congruent. It should be is similar to triangle CFD. So BFE is similar to triangle CFD. And if you notice, it's actually not the similar, it's not side angle side that we're learning today. This is yesterday's similarity statement because we have two angles, angle, angle, and angle, angle. So this is angle, angle similarity. Okay, we're going to go ahead and move on to the back side of our notes. We're going to look at example 7 in class, and let's go ahead and look at example 8 right now. So we know that triangle FGH is similar to triangle JKL. We need to find the value of angle X. So we already know these triangles are similar. Notice we have the interior angle, right? I'm sorry, the included angle. So these two sides have to be proportional. So we need to go ahead and set up a proportion. So GH, which is x minus 5, corresponds with KL, which is 10. So that has to equal the other corresponding sides, which would be FH, which is x plus 3, over its corresponding side of 20. So now we have a proportion that we would simply cross multiply, our butterfly method. It does not matter which one you want to start with. I'll just start with the 10 times the x plus 3. Remember, you have to distribute in this situation, so put parentheses around your binomials. 20 times the binomial of x minus 5, and then we need to distribute. So 10 times x is 10x, plus 10 times 3 is 30, and that's equal to 20 times x, which is 20x, and 20 times negative 5, which is negative 100. Okay, we now have a baby, a 10x, and a mama, a 20x. We're going to go ahead and subtract the 10x and bring it to the mama. We have 30 is equal to 20x minus 10x is 10x minus 100. Then you would add 100 to both sides. So I'm going to rewrite it up here. 100 plus 30 is 130. is equal to 10x. And last step, divide by 10. So x is 13. And that's all we need to do because all it asked for was the value of x. Okay, the last problem we're going to look at today is example number 9. To measure the distance between E and F across the lake, so this is a lake back here, a surveyor at point S, so a guy is standing right here surveying, locates point E, F, G, and H as shown. So he's located all these points around the lake. What is EF? So this is asking us what is the distance across the lake from E to F. Okay, in order to better understand this problem, what I would do is I would separate the triangles because it's easier to read and understand. So you have a giant triangle, and you actually have a smaller triangle located inside the giant triangle. And I'm going to go ahead and relabel these sides. So we have F to S, and then this one is E, this one is G, H, and S, and then I'm going to relabel the sides as well. So F to S is the 27 plus the 9. Okay, obviously this is not drawn to scale because this part does not look like it's bigger than this part, but that doesn't matter. We still need to add it up all the way across, so this would be 36. 27 plus 9 is 36. And then 30 and 10 all the way across here would be 40. We do not know what that slide length is. We know that G to H is 6, G to S is 9, and H to S is 10. So now we can easily set up a proportion. It does not matter if you want to use the corresponding sides of FS and GS or ES and HS. It does not matter which ones. So I'm just going to pick the top one since it's there. So FS is 36, which corresponds with GS 9. And we're looking for FE, so we have to use X, because it's on the big triangle, which corresponds with GH on the small triangle, which is 6. So then we go ahead and simply simplify, cross multiply our proportion. 9 times x, 9x. 36 times 6 is 216. Divide by 9. 216 divided by 9 is 24. So the distance across the lake from E to F is 24 meters.